All right, welcome back to Computer Science E76. This is our second lecture on iOS. So tonight we'll continue our conversation about Objective-C and then dive headfirst into some actual iPhone and iPad-like development. But first, a few fun facts from the survey that everyone filled out earlier in the semester. Recall that we asked you, what do you do for a living? Where do you work? What platforms do you use? What mobile devices do you use? And just to give you a sense of who you are, this is a visualization of the most frequently occurring words in people's job descriptions. So we have quite a number of software-related folks: engineer, web, senior, developer, and then if you read in some of the smaller print, you'll see some other text as well. But this is available online if you'd like to zoom in and look at it in higher fidelity, but perhaps no surprises there. A lot of you are from Harvard. When asked to describe your places of employment, a lot of you from university and school and Berkman Center and business, and then throughout there are a whole number of other companies. Realized that the opt-in rate was just over 50%, so there's actually twice as many folks with different titles and job descriptions here. This just depicts those who opted in to the sharing of information. You'll see on the help site, help.cs76.net, that we encourage, or actually my email this morning encourages you to just reach out to us at the help address if you'd like to meet any of your classmates that you see described on the Google document that we shared this morning. As for OSs used regularly, Mac OS has a slight lead here in terms of versions, but if you add up all of the Windows users, this is kind of funny, does seem to be consistent with trends in the real world. But a lot of you are still using XP, about the same using 7, and some of you are indeed on Vista. In terms of the devices that you all use, definitely a lot of iPhones and iPads and iPod Touches in the iOS space, but a non-trivial number of iPhones, a couple of Android tablets. Granted, it was a little soon, 0 Windows 7 phones, but recall that that just shipped a few months ago now, but 0 WebOS phones as well. So just to give you a sense of who you are, we actually have a nice smattering from all the various platforms that at least we're focusing on in this particular course. And you're most excited for Android 39%, web 12%, and iOS just ekes out this semester 48%. So without further ado, some more on iOS. So recall that last week we dove into Objective-C, which syntactically is a bit messier than languages with which you might be familiar. It's at least a little bit different. But recall that we introduced this notion of a header file, a .h file. This is carried over from the language C. In header files, do you place your class declarations, what they look like, what instance variables go inside them. You might put other import or include statements so as to include other header files within your own projects. On the .m files, though, is where you actually implement your methods and actually synthesize properties we'll discuss today. So those are really the two primary files, and you'll see starting tonight and with the upcoming projects that you'll, when using Xcode in particular, you'll get a non-trivial number of files automatically generated for you. But typically they will end with these extensions, though there's a couple of others that we saw last week, including quick trivia, a .pch file. Anyone recall what that was? Yeah, precompiled header. So you'll usually get one of those for free when you use one of the Xcode templates, and it's super short. It's essentially a header file, like a .h file, but it contains lines of code that essentially get prepended to all of your files so that you can have essentially some global import statements on all of your files. But you'll get one of those for free, but for the most part, we'll start focusing on these .h, .m, and soon .nib, XIB files. So we talked about instance variables. We've seen these in Java. You've seen these perhaps in other languages. By default, when you declare an instance variable, as we'll see recurringly, it gets a status of protected. But there is the notion of private and public, but we won't dwell on that so much just yet until we dive into an example in a moment. Class methods. Any method, recall, that starts with a plus sign is a class or static method. That means you can call that method on a class without doing what? Without actually instantiating an object thereof. So alloc, which is sort of the analog to the new operator in some languages, is how you allocate space for an object of a particular class. Meanwhile, you have instance methods, those that start with hyphens to distinguish them from the plus signs. And here are some examples we'll see in just a bit, whereby this first one here is an instance method, which means you can only call this method if you've already instantiated an object. The context here, as we'll see in a moment, is a student object, and I decided arbitrarily a student will have a name and an age, but that's it for now. So this means that any student object has a getter, it seems, an accessor method called age, age that returns an int. It also has a setter called setAge that returns void but takes an int as its argument. And then it appears to have an initialization method, two of them in fact, one just called init, which typically is the default by convention, another of which is called init with name and age. And recall, this was perhaps the first syntactic curiosity we saw with Objective-C, in that you kind of have these named parameters, but the order does matter. And the general guidance in choosing names for your methods is that typically, stylistically, they tend to read almost like a sentence, where you might literally say, call init with name and age. It just so happens that when you pass a message of this form to an object, as we'll soon do ourselves, you parameterize it here inside of the name, if you will, and then also here, as implied by the colons. But we'll start to see this hands-on very soon. But at this point in the story, really there's no new features of the language, nothing that you couldn't do via some other syntax in Java, but really now we're just acclimating to the syntax. Now, the syntax that's also most striking, besides the pluses and minuses we just saw, are how you invoke methods. So you don't call a method in Objective-C, rather you pass a message to an object that then responds to that message by calling a method, essentially. But semantically, folks, generally, it is correct to say passing messages. So in this top line here, I have somehow, presumably, instantiated a student object and called it student in all lowercase, and then I'm just calling age. Now, in this context, that's a useless method call. It's a useless message to pass because I'm not actually doing anything with the return value. But that's how I would call the getter. This is how I would call the setter. And then if I wanted to call the initialization method, or the more explicit initialization method, I can pass in two parameters in this way. And again, just as a teaser, and we'll start writing real code shortly, the @ sign denotes what? Because that was a new piece of syntax, perhaps. Yeah, an NS string. So that means that quote unquote Alice is not a string in the C style of an array of characters, chars, but rather it's an actual object of type NS string, which means there are methods associated with it, and it is in fact distinct from a C-based string. So just so we have the jargon there, these names of these methods, you would generally refer to them as selectors. And this will be useful jargon to have because we'll actually see some interesting syntax before long whereby you can pass one method the name of another, and that name is generally referred to as a selector. But more on that when we actually need to do that. So let's actually dive into an example. So I'm going to go ahead and load up Xcode. Some of the examples tonight I'll start to do on the fly. Some of them I'll grab some prefabbed code from last week's and this week's zip file online just for speed's sake. But recall that last week we actually didn't write until the very end of class a single iOS application. We did all Macintosh-based applications because we just wanted a little sandbox in which to write some command line utilities to just play with syntax. So let's do just a couple more of those here, but to use them as an opportunity to discuss some of the actual features of Objective-C that we can then use and deploy in an iOS context. So to be clear, I started out with this window here. Choose a new template for your project. I wanted a super simple template, so I chose Mac OS X application, command line tool. And the upside of this for now is that it gives me as few pieces of code as possible. I can focus on writing almost everything myself. It's asking me for my product name. I'm going to call this the Student1 project. The type here is Foundation, which implies using Objective-C, but also gives me some import statements by default. So I'm going to click Next there. I'm going to go ahead and save the files on my desktop or whatnot. And recall that this was one of the first screens we saw last week. So more detail than we care about right now. In fact, even though the font is small, I'll zoom in as needed here. But at the top left are all of our files. And you'll see that under that list of files, we had one interesting one for now. So at the top left here, we have these. Main.m, student1.1, some supporting files. There's that PCH file, and then mention of these frameworks and products. So we're going to focus for now on just main.m. And in main.m, I have the opportunity now to start writing a program. So what might we want this program to do? Well, very simply, I'm going to go ahead and whip up the following. Actually, let me go ahead and open this for time's sake. Go into our Student1 example. And let's take a look at this main.m. So in this main.m, notice it starts off fairly C-like. We've got some import statements at the top. Import is almost identical in spirit to include, but it avoids some cycles, potentially, multiple inclusions. Then I have a prototype. What's the purpose of a prototype in C or Objective-C? This is the function signature, but why bother if I'm clearly not implementing it yet at this point in the story? Yeah?
So you can use it before you define its body.
Exactly. So I can actually call it in code that chronologically comes before anything else in my file. So it's a hint to the compiler that expect me to implement at some point a function called greet. It's going to take a pointer to a student as its argument, but I don't have time to implement it just yet for you. It's somewhere else. So what might this program do? Well, recall in C, as well as in our Objective-C environment, the default function that gets called, that we've gotten a bit of template code for almost always, is called main. Main can take some command line arguments, but we're not going to use them for now, or really ever for our purposes. And we saw this line of code here. And we waved our hands at it last week, but we'll talk a bit more about memory management today. But know that in Objective-C, you do have to allocate memory quite often. And the method we've discussed thus far is called alloc. Well, when you alloc memory, you're responsible ultimately for releasing that same memory. But not always, because you can imagine scenarios where it'd be pretty useful to call a method that itself returns a chunk of memory that it allocated for you. But now that begs the question, then who deallocates it? That function? Do you have to call that function again to actually deallocate the memory? Do you do it? Well, in that sticky situation, what that method would have done is instead specify that this chunk of memory it allocated will be auto-released. And that's sort of a flag to the runtime that says, make sure to release this memory eventually without the user, the caller, having to manually call the equivalent of release. But more on that in a moment. But that's what this line of code is referring to here. It's telling the computer, I need a chunk of memory just in case I call or I write methods that need to allocate memory that's going to be auto-released. It's not quite garbage collected. We'll come back to that. So you need this pool of memory. If we fast forward to the bottom of this program, at the end of main, what you'll see is that that pool is eventually, quote unquote, drained, which means that anything you've put into that pool will be freed up for you. So it's a useful thing and necessary, and you can actually allocate more than just one pool, but we'll leave that for another day. So what's this program going to do? Well, let's just look at some syntax, and hopefully it'll become more and more readable fairly quickly. So here is going to be a student object called Alice. So Alice is the name of my variable. The type of that variable is a pointer to a student. So that's hopefully familiar syntax from last week. On the right-hand side in English, what is this expression doing for me? Yeah, it's allocating a chunk of memory big enough to hold a student object. More specifically, I'm passing the student class a message, specifically the name of a class method whose purpose in life, again, is to allocate memory and then return a pointer there too. So at this point in the story, inside of Alice is essentially the address of that chunk of memory in RAM that I can now treat as a student object. Well, here's how I'm going to use my syntax. I'm actually going to use some C style or C++ style in syntax here and say Alice arrow age and Alice arrow name is going to get 20 and Alice respectively. So what's going on here? Well, these seem to be instance variables. And let me confirm this, this suspicion. If I open up student.h, which is where I've declared this class called student, sure enough, there's not all that much to it. So the stuff at the top is comments. This is an import line that says, give me access to all of Apple's libraries. The next few lines are the class definition. So recall that last week we said that what Java calls a class, Objective-C calls an interface. So at interface means here comes my class declaration. It inherits from this sort of grandfather of objects called NSObjects, though you can inherit from other objects, but this is the most common. Here I have a sort of C++ style at public specifier that says everything I write on the lines that follow should be public, which means any class, any method can access these properties by way of that arrow notation. Not the best approach, but this is example one. Wanted to keep it simple is all. We'll introduce getters and setters in a moment. Now, what are the instance variables that every student will have? Well, an age, which I'm going to sort of lazily just say is an int, but that would lead me to negative options, but I'll deal with that later. And then an NSString star for name. You would never just write NSString name. You'll always prefix it with the star to denote a pointer there too. And we'll see why it is that we're passing addresses around all the time. Close curly brace. At end, normally I could put class methods here, but I don't have any yet, so that's it. So really, my class, called student at this point in the story, is just a glorified C struct, because I've not associated any methods with the student. I'm just wrapping these two pieces of data, an age and a name. So if I go back now to main.m, hopefully this is clear. Whereas Java would use a dot notation, C, C++, Objective-C would use arrow notation here, but this means the Alice object's age instance variable gets 20, and then the name is set accordingly as well. So greet, there's that function I promised I'd implement called greet. I'm passing Alice by pointer to that function. For now, let's assume that that just greets Alice and says, hi Alice, how are you? Or something like that. This line of code, though, here is important, and it's a critical habit to get into. You must call release if you yourself have allocated memory by calling, in this case, the alloc method. But there's a few others we'll see, including new and copy and a couple of other ones as well. But alloc for now is certainly going to be the most common. So mental note, written note, anytime you call alloc, you must call release. And the disclaimer there is unless you do auto release, but we'll come back to that. So it's very much like malloc in free or new and delete or any non-garbage collected language where you need to have both calls in there explicitly. Bob's code, almost identical. I'm allocating a second object for him, storing in Bob. Age is going to be slightly different. Name is slightly different. Greet him, release him, drain the pool, and that's it. Now, what is the greet method defined as looking like? Well, let's scroll down to the bottom here. At the bottom here, we have the function greet, returns void because it doesn't need to return anything, called greet, takes a pointer to a student here, and all I'm doing is using sort of our new equivalent of printf. If I just want some command line debugging output, nslog, which takes an ns string as its argument, and it's going to say, hello, placeholder. This is the placeholder for an ns string. I see that you are number placeholder, years old, \n. Now, how do I plug in those placeholders values? Well, using the same syntax as with which I set them. S arrow name, S arrow age, done. So the end result of this program, once I actually run it, which I can do by clicking the Run button in Xcode's top left corner or by hitting Command R, is it will run. At the bottom of my screen, I'll get my little debugger window. And if we zoom in here, it says in bold, hello, Alice. I see that you are 20 years old. Hello, Bob. I see that you are 21 years old. All right, a whirlwind tour through a relatively simple example that has very few features, but any questions? Yeah?
Did you mention before, I'm sorry if you did, is there a dot notation equivalent to the arrow notation that you're using there?
Is there a dot notation equivalent to the arrow notation? Yes. I would not get into this habit, at least with Objective-C, since you'll almost never use this notation anyway, at least with the foundation classes. But yes, Bob arrow age is actually syntactically equivalent to star bob dot age gets 21. And this, you can infer this if by a few leaps from last week, whereby star bob says go there, the dot notation means access the property, or rather the instance variable that's right there. The arrow operator, by contrast, does both of those in one breath for you. So correct, but more readable, I would say, is generally the arrow. Yeah?
I know there's more auto-release ahead, but in this program, when we explicitly allocated for these two students, did the auto-release pool get used at all?
Not necessarily, though we did specify that we want these constant strings. In this case, probably the compiler would be smart enough to just allocate those statically, since they're immutable. But as a matter of good practice, it should always be included nonetheless, because you don't necessarily know what's going on underneath the hood in any functions you yourself are calling. So it is necessary as a top-level function call. Good question. Yeah? Uh-huh. Oh, good question. I don't think it will work at all. The syntax, weird though it is to say at public, and then everything that follows on the subsequent lines will be public. If you want to change modes, down here you would just say at private or at protected, so you can toggle back and forth, but you would not use curly braces. C++ is a little different in that you'd use a colon, and of course Java you would do it one per line. It's just the syntactic decision they made. And in fact, you'll rarely, at least certainly for the examples we start doing now, you'll rarely need to bother doing that since protected usually suffices. But for now, I actually wanted to open up access to these instance variables just so I could get at the data without writing methods yet. Yeah?
In a phone application,
It's something you created or a small team creates and it's a bundle. It's an isolated thing.
Good question. So if you're the only person writing this program or you're doing it in a small team, why bother jumping through the hoops of getters and setters as we're about to do it?
I just meant the protection level.
Oh, but the what? Oh. Well, so that was the opposite. So the alternative to doing this is actually making it private or protected, but then providing a programmatic access to the data. Generally, what you've proposed, sort of just making everything public because it's simple and because you're the only one writing the code, it's fine, but starts to break down quickly, especially if your projects grow in scope, and if you two want to change implementation details, and you realize, you know what, I actually really implemented the name field poorly, I'm leaking memory, or I'm not retaining copy, you're doing something wrong. I mean, these layers of abstraction that developers have built up are generally a good thing for reasons, but for small projects, I mean, even I would not bother writing getters and setters if it's just more time than I want to spend on it. But it's a design decision. It's not strictly necessary, technically. All right, so what's bad about this? Well, I can respond to that rhetorical question with the former question. Well, we're not really protecting this data in any way. We're committing for eternity to calling these data members age and name. And what about name, though? I could imagine down the road actually re-implementing name such that I tease apart first name, middle name, last name. But here's a very simple example where if I've hard-coded in name everywhere, there's no chance of my actually changing that, improving it in the future as I could with a getter if I've just hard-coded in arrow name. So long story short, if I actually want to start encapsulating my code a little more effectively with an eye to the future, let's take a look at students 2 in Xcode. So students 2, I actually made a couple of decisions here. So notice what I've done in student.h. So this is among our printouts, but you will notice tonight that I went back after last week and changed some of our implementations. So do rely on the PDF that's online after you leave tonight, as well as at the zip file that's online. The printout from last week is slightly out of date now. But here's the latest version of students 2. This is student.h. So I've decided I can do better than that lazy approach to implementing a class called student. I'm going to actually implement some getters and setters now. So syntactically, how might I do this? Well, the top of the file is going to be identical for now, though I did make the design decision to prefix my instance variables with an underscore, just so that later on it's more obvious to me, the dummy, what's an instance variable and what's like a local variable. Just a convention that I chose to go with here. But notice each is of int and ns string star. So the types have not changed. Notice I close my curly brace. This might be one of these first weird stylistic decisions, but the instance variables go inside the curly braces. The method declarations go outside, but still in between at interface and at end. So here come my method declarations. The minus sign means what? Instance method, which means you've got to instantiate a student object if you want to call any of these. If it were instead a plus, then you wouldn't have to. Now let's point out the obvious. Absent at the already is that alloc method. How could I possibly ever allocate a student object if there's no mention of plus or alloc? It's an NS object. So because this class descends from NS object, you get a whole bunch of methods for free. Some instance, some class methods. Among them, there's sort of fundamentals like alloc and init and a number of others. So we don't have to override those if we don't want. We certainly inherit them for free. So I do want to implement a setter and a getter for age. I'm going to, with some foresight in mind, declare my getter to be identically named to the instance variable without the underscore. And set age, notice the pattern. It's called age, so I'm going to do lowercase set capital age. And that's just a habit I'm going to get into right now. As a setter, it doesn't need to return anything, but it does need to take something, namely an integer, and I'm going to call it age here. How about my name setter and getter? Well, I'm going to take the same approach, but notice it's an NS string star for the parameter and the return value for the setter and getter respectively. So now, how do I actually use these things? Well, let's go to this version of main.m. In this version of main, pretty much starts out identically to the one before, but now notice, instead of using that arrow notation, I'm now using the methods I've just defined. So I have Alice declared at top there. I'm allocating a student object. Then I am calling Alice's setAge method by passing in this message, setAge:20. So this is how I call the setter. Notice there's no equal sign on the left. There's no assignment because it's just a setter whose return value is void. I do the same thing for Alice. Again, beware, a common newbie mistake would be to omit accidentally the @ sign, but Xcode will generally yell at you in yellow or red text if you make an error like that. I then call greet Alice, release Alice, and then Bob is uninteresting at that point because it's mostly copy-paste. So the only difference here is instead of presumptuously looking inside of this object and getting the age field and the name field, now I'm programmatically asking the object, give me your age, give me your name, which now means in the future I can change the implementation details of age and name, which we'll see in a moment is actually a good thing for reasons of memory management. And the caller, my main.m or any friend I gave this student class to, doesn't have to worry about the convention changing on him or her. So now let's look then at the implementation of these methods. So in student.m is where I've actually implemented these methods. So let's see the syntax here. At the top of the file, I'm importing student.h so that the compiler knows when I mention capital STUDENT what in the world I'm talking about. Well, it's the class we just looked at a moment ago. At the top here, I don't have @interface, I have @implementation. And I specify the name of the class I'm implementing, and then I proceed to implement my methods. So the minus sign again means here comes a instance method. I specify the return value and the name. This is copied and pasted from the .h file. The only thing I've done differently is instead of ending that line with a semicolon in the .h file, I'm now diving into curly braces so I can actually implement this thing. Now the getter is pretty straightforward. What does it mean to get my age? Well, it means to get the value of the instance variable that's representing my age, which is _age. So return _age is as simple as that. How about setting the age? It too is pretty simple. So when I want to set someone's age, it takes an int, call it age, and here already you see one of the values of slightly distinguishing instance variables from local variables or parameters. Because I've called these something different, I can now do a very clean one-liner like this, where it's clear that input is getting set to the instance variable is taking on the value of the input. You can't do, for instance, this dot as you could in Java to achieve that in a setter here. So this is pretty straightforward, even if the syntax is new. But what's interesting about a name is that it's actually an object. And anytime you deal with objects, it feels like it gets a little more complex. You might have to deal with memory management. And sure enough, let's see what's going on here. My getter for the name class, getter is just going to do the obvious. But setting's a little interesting because we alluded earlier to this idea that when you allocate memory, you eventually have to release it. But in Objective-C, you kind of have to signify to the rest of the world if you, some other method altogether, wants to also hang on to that string or that object. If you want your own copy of it, do you just want a pointer to the original? In short, methods kind of have to communicate between one another through the runtime, through the language. And so we can do this by saying, I want to retain this object, or I want to copy this object. And what you'll see is that Objective-C, at least on the iPhone, on the iOS platform, it doesn't do garbage collection for you like Java. It doesn't kind of infer from your code when it's safe to actually take back memory that you asked for previously by calling new. Rather, Objective-C implements something called reference counting, whereby when you call alloc, you are indeed given a chunk of memory, and that chunk of memory's so-called reference count is by default 1. Which means one person, one method, one entity in your program cares about that chunk of memory. So what does release do? Well, just intuitively, if you were implementing release, how would you implement release? Exactly. Decrement a chunk of memory's reference count, so it would go in this case from 1 to 0. At that point, the device is allowed to take back that memory. Reference counting means that so long as you have a non-zero reference count, it's not going to get reclaimed, and except in dire circumstances whereby the user's just running way too many applications and they just have to kill your program. But the memory will only be reclaimed by the operating system once the reference count is 0. So this means if you're implementing a method like a setter, and a setter by definition has to set a value equal to something else, if you want to set a value that happens to be a pointer, you kind of have to tell the operating system, I want to hang on to this chunk of memory, in addition to anyone else who wants to hang on to this chunk of memory. So the keyword with which you do that is a keyword called retain. Now, we're not going to use that in just a moment, but there's going to be an alternative. But retain would take a reference count of 1 to 2, which means even if the original guy who allocated the chunk of memory, the student object in question, says release, I no longer care about this object, it will get decremented, the reference count, to 1. But that's OK, because now this other guy who's hanging on to that chunk of memory is not going to have it pulled out from under him just because it's effectively released outside of his context. So on the downside of this wonderfully symmetric approach of retaining and releasing memory is that the burden really is on you, the programmer, to get the addition and the subtraction right. Otherwise, memory leaks occur, and we'll look probably next week at how you can, with various tools, chase down memory leaks. But for now, probably the best habit to get into is any time you write a line of code that uses alloc, 5 seconds later, make sure you do the corresponding release, or we'll see auto-release call, and then fill in the code in between. So you get into that habit now. So let's see how we might implement setName. Well, I'm going to go ahead and let me cheat for just a moment. And I'm just going to do this with setName. So in my setName method, I am just going to do the same thing as before. Name gets name. Now this looks identical now to how we implemented age. But what's the problem here? Well, we talked last week about pointers, and indeed name is a pointer to a string. So if I just very naively say underscore name gets name, I'm literally copying the pointer, the address, inside of name and storing it inside of underscore name. And so now this student object, Alice, if you will, is hanging on to that same pointer address. But according to the story I just told earlier, at that point in the story, the so-called retain count for that string is just by default 1, which means if after this setter returns, and this setter is going to return in an instant because it's so short, after this setter returns, suppose that main, the main function, decides, I don't really care about this string anymore because I gave it to Alice. Alice had better have hung on to her name. Well, Alice didn't really hang on to her name here. All she did is duplicate that pointer. So if main then allows that memory to get reclaimed by the operating system, at this point in the story, Alice is going to be clinging to a pointer that's just no longer valid. It's pointing to a chunk of memory in RAM, but that no longer belongs to anyone because the operating system took it back. So intuitively, what we really want to do here is somehow retain the object stored in this name variable, retain the string, so we bump up its reference count by 1 so that it doesn't matter what happens outside the context of Alice. She has put her stake in the ground and said, I want to at least retain this object even if no one else cares about it anymore. So it turns out that we need to be a little more clever than that. So one way we could do this is as follows. We can say name retain, literally as simple as that, and now I'm going to go ahead and retain that pointer. So I bump up the reference count, and then I assign the value here. But strings are kind of an interesting corner case, but a common corner case, in that, as we'll see before long, there are NS strings in the world, but there's also this subclass called NS mutable string. Mutable meaning you can change it. So the problem that we would at some point in our lives encounter if we just retain strings in this way is that if I actually handed Alice a mutable string, an NS mutable string object, and then I, being main, change that string, I could change Alice's name on her without ever actually calling her setter, which if nothing else is semantically a bad thing, and it's probably incorrect. So really, if Alice wants to ensure that the object she's been handed, the string she's been handed, can be touched thereafter by no one other than her, well, she can't just retain the original object, she should really copy that object. And so the second rule of thumb with regard to memory management is going to be anytime you alloc or copy an object, you must later release it somehow. So we have to make a mental note that in Alice's destructor, to borrow the jargon from C++, we have to remember at some point in the story to release the memory if we're about to retain or copy it. And that method is going to be called in Objective-C the dealloc method, which Java does not have an analog of, but C++ does. So I'm going to go ahead and paste back my original code, which is correct. There's this other corner case that we won't dwell on for now, but funky things can happen if, by accident or intentionally, I pass to Alice the same name that she's already hanging on to, literally the same object. So you can end up actually retaining or releasing an incorrect number of times. And so we actually want to hedge against this and check, you know what, if my name already equals the name you're going to give me, forget it. I'm not doing anything because I got it right the first time. I'm not going to screw things up. But rather, if they do not equal the same thing, because this is nil, the equivalent of 0 or null, and therefore I'm getting a new name, or if it's just my name's being changed from Alice to something else altogether, okay, then I'm going to release the name I was hanging on to, whatever my original name was. Then I'm going to copy into this instance variable the name I've been given. So now, at this point in the story, who knows what the reference count of this original name is. But because we've made a copy of it, now the new copy's reference count is 1, which just means mental note. Alice eventually has got to free up this memory. Yeah?
So if we use property and synthesize, as opposed to creating our own setters and getters, do we get that for free?
Short answer, yes. But playful answer, I don't know what you're talking about yet, because that's example 3. So yes, we will actually ameliorate some of this headache and the tediousness of implementing this for many, many different instance variables through precisely the mechanisms that you alluded to. So more on synthesize and properties in just a moment. So I said a moment ago, as soon as you call copy or alloc, you better within seconds actually free that memory or release it. So you know what? Sure enough, I'm going to go ahead and preemptively implement in my student.m file a dealloc method whose return type is by definition void, where I'm going to do 2 things. One, I'm going to free the underscore name instance variable by calling release, which means the reference count that was a moment ago 1 is now 0, which means the operating system is free to take my name away. I don't care about it anymore. And then for good measure, and as a matter of best practice, I'm also going to call my superclass's dealloc method, just in case he or she has to do some housekeeping as well. Now in this case, NSObject's not going to really clean anything up, but certainly a good habit to get into and make another mental or written note. This is the only situation in which you, the programmer, should ever call dealloc. You should never call dealloc unless it is inside of one of your own dealloc methods. Otherwise, you should be using release, or as we'll eventually see, auto release. So in short, don't ever call dealloc, except in this one case here. Yeah, question. Wonderful question. What happens if name, underscore name, is never set? Well, the beautiful thing about nil, this somewhat different incarnation of the notion of 0 or null, is that in Objective-C, it's perfectly legitimate to send messages to nil, whereas C, C++, bad things happen. It crashes if you dereference null. The nice feature, for better or for worse, about nil is that it will just ignore messages that are sent to it. Now, this is a good thing in that with one line of code, I can release the memory even if no memory's been allocated. It's just going to ignore it. The downside is, arguably, you're now kind of getting a little lazy potentially, and you might mask what otherwise might be bugs. Maybe I'm calling release because I've been dumb and I got my arithmetic wrong and I'm releasing 10 times, but I only allocated once. So that's 9 mistakes that would essentially be pushed under the rug here. But in general, it's a nice thing because the alternative would be to write, much like you would in many languages, something like if name is not equal to nil, then go ahead and do that. It just cleans up the code, which is one of the selling points of using nil in this way. Yes, question top right. Yeah.
Do you have to prototype dealloc in the interface?
Good question. Do you have to put a declaration of dealloc in your .h file? You can. Short answer, no, you don't have to, because it's already in NSObject.h. So it's already been declared as part of the class hierarchy for you. So might as well not bother cluttering up your .h file, but it would not break things if you did. Yeah?
If you have an init function that does not set name at that time, is it assumed that name is nil, or is it required to set it to nil?
Good question. It would be by default nil or 0 or 0.0 depending on the underlying data type.
Okay, you can count on that.
Yes. Yeah. There are known defaults for instance variables. And one other question here. Yeah.
So you don't need to release native type like H, right?
Correct, exactly. You only need to retain and alloc and release objects, so capital letter classes. Primitives like lowercase int, long, double float, you don't have to do anything with them because they are just raw sequences of bits that just get copied and don't need memory allocation dynamically. Good question. All right, so can we do better? Because frankly, even though this is a silly example, if those of you with Java backgrounds have probably written classes with half a dozen different instance variables or getters and setters, you end up just copying and pasting a lot of code again and again and again. And now, frankly, it feels like it's going to quickly get bug prone if I have to actually think about implementing my getters and setters with regard to memory management, which again in Java is handled for you. So can't the compiler help me here? Well, indeed it can. So this is Students 3 project. And I'm going to go ahead and open up student.h now and notice some new syntax. And frankly, this is one of the things that starts to hurt the brain quickly, but once you know what the options are, I think it very quickly becomes more readable. So some new pieces of syntax. This is a new version of student.h. This is in our third version of students, so students 3. The class declaration is identical up top with regard to instance variables. I've got an age and a name. But now notice this. At the bottom is identical. I've got my setters and getters declared exactly as before. But I've done some funky things here. I now have introduced this new keyword, @property, with this comma-separated list of parameters, if you will, or settings, assign, non-atomic, read-write. Copy, non-atomic, read-write. Then int age and ns-string star name. There's going to be motivation for this in a moment, and I can clean up this code further, but let's spoil it first by looking at main.m. How can I use what I've just done? Well, it turns out that now that I've declared properties, I get a new feature in Objective-C 2.0. I no longer have to explicitly call a method called setAge, or name, or setName. Now I can use dot notation. And the compiler will infer for me whether or not to call the getter or the setter, depending on whether there's an equal sign there, implying assignment, and therefore a need for the setter. So I allocate Alice, just as before. As an aside, notice I'm not yet even using an init method for Alice. Init methods are not strictly necessary. Alloc is necessary if you want the memory. You don't need to call init. In fact, it's just a convention that it's even called init or something similar. I'm manually initializing my instance variables here, but we'll improve upon that shortly too. So Alice.age gets 20. Alice.name gets @Alice. So now I've gone from version 1 with my arrow notation, which was very low level. I was directly accessing the instance variables. I took that up one layer of abstraction and introduced getters and setters. But it was a little messy in that I had to pass the age message with the square brackets, the set age message with the square brackets. Just felt a little messy. Now, I apparently can replace version 2 with version 3 and just use dot. And because there's an assignment operator on this line of code, it's going to sort of auto-magically invoke a method that by convention is called setAge. On the next line of code, it's going to, by convention, invoke a method called setName. So I deliberately named my messages earlier, or my selectors earlier, to be set_age, set_name, because it turns out this is going to be useful in just a moment when I eliminate even more of my code. Let me wave my hand at the rest of this, because Bob is copy-pasted from Alice. Greet is the same. Release is the same. But for now, any questions on this introduction of the dot syntax? Yeah?
So is it, so when you want to get the setup, must you name it by the name of the property you want, the variable you want to set name, or can you just set something else?
Excellent question. So let me go back to the header file and restate the question here. In my header file, notice that I said @property, then this parenthetical, then int age. Because I've said age, AGE there, and because I've said name here, these will be the names of my properties. Now, I can change that. They can be completely unrelated to my instance variables, but as a matter of sanity, it's good to name them almost or exactly the same. But the names that you can use after a dot derive from these two lines here, not from these two lines here. In just a moment, I'm going to clean this up, and I'm even going to get rid of those because they're just a waste of my time and a potential distraction. So now let's see how we can use this. Well, if I now look at student.m, which is where I'm going to implement this class, notice that the implementation is the same. So this is copied and pasted from my previous code. Because my implementation of students hasn't changed, all I've added is some syntactic sugar, as it's called, by using @property twice, so that now I have the capacity to use dot notation in my m file. So those two lines change in the .h. My main.m file, I now use those dot properties. But now let's really leverage this feature for why it was added. So I'm going to open up version 4 of students. And here, we're going to see the following in my h file. Wow, I'm really chipping away at this. What do you no longer see in my .h file for student.h? There's no instance variables. There's no getters, there's no setters, right? This almost feels like a step backwards, but notice that I did retain these two lines, @property. So what's nice about the latest incarnation of Objective-C and the related compilers is that now I'm declaring age and name, which means I can use this dot notation. But you know what's really cool is if now I go to student.m, with these magical two lines, I can automatically have synthesized for me a method called age and a message called setAge for free. Compiler will generate and paste in that code for me. I can automatically generate a method called setName, and the compiler will generate that code for me. All I have to do is tell the compiler or ask the compiler, please do this for me. You do that by way of the @synthesize keyword, which means go take a look at the properties I declared and please synthesize the following property. Now, the equal sign and underscore age here is actually not strictly necessary, but it's the latest sort of convention recommended in the latest version of Xcode. This is saying call my property age, call my property name, but in addition to dynamically creating these methods called age and setAge, name and setName, also go ahead and generate for me 2 instance variables, one called underscore age, one called underscore name, and map the properties to those instance variables accordingly. So in the previous version, I did that exactly the same way, but manually, by writing a dozen or 2 lines of code, because I used underscores in my own code. Now I'm just saying, forget it. I'm tired of writing all this damn copy-paste boilerplate code all these years. Now I want the compiler to help me a little bit with this programming methodology with getters and setters, and these 2 magical lines do exactly that. Generates the instance variables with these names. If I left them out, the instance variables would be called these, literally, which might be fine if you're OK with the convention, and I just had to specify in the .h file the 2 property lines. Yeah? In the compiler, not in the preprocessor. This is a feature of the front-end compiler. And also, just to be clear, Xcode will recognize these methods as existing. So in a moment or in the projects, when you're actually writing code, you'll see that you can type setAge, and it will start to autocomplete, even though you yourself never even mentioned that method's name. Yeah?
So if you wanted your setter to actually do more than just set the age variable, you would just write an explicit setter. You couldn't.
Exactly. So we're going to see this in a moment, too. Very perfect segues here tonight. So we can see that, what if I want 3 out of the 4 methods dynamically generated for me because I want to override the setter method for one of these things? You can just implement that setter method yourself, and it will take priority over any automatically generated code. And so we'll see that, I think, in the next example. Yeah?
So if name is an NS string, do we know that it does all the things that your handwritten setter showed?
It does. It is what the code I wrote in the previous example to implement setAge and setName is identical functionally to the code that Synthesize will generate for me because of the attributes I consciously applied to the properties. So we waved our hand a moment ago at these parentheticals. What's really going on here? Well, let's look at the more interesting one first. The NS string name. Recall we had this discussion just a few minutes ago about needing to retain it or make a copy of that name. Well, it's not sufficient then to just say to the compiler, go ahead and implement this setter for me. I have to tell the compiler, how do you want me to implement this setter? Do you want to retain the objects you're passed? Do you want to copy them? Do you want to just assign them blindly, as in the incorrect first version? Well, I'm specifically stating parenthetically, and the order of these things doesn't matter, copy, which means make sure to add that line of code that I manually added a few moments ago that had the copy line, so that I'm preserving, I'm asking for my own copy of that string and taking on a reference count of 1. Non-atomic, for our purposes, is almost always fine to use. It specifies that you're not using multiple threads. You won't potentially run into race conditions. So there's a slight performance benefit of saying, I don't need atomicity around this instance variable. It's fine to just leave that special code out, as I did manually. Read-write just means give me a getter and a setter. If I said read only, it would give me just a getter. So these are really the 3 possible options that would apply to something like an NS string. And notice I used copy because it's a string, and I worried about this corner case of mutable strings and things changing on me. So for now, good rule of thumb, if it's an NS string, use the copy semantics. Now as for this int called age, I can actually be a little lazier here because it's just a primitive. It's 32 bits. And so I don't need to jump through hoops about retaining and releasing because there's no objects involved. So I'm just going to say, create me a setter that just does assignment. Very simple one-liner like I myself wrote. Non-atomic because I don't care about multi-threading. Read-write because I want a getter and a setter. So through those 3 hints separated by commas, I'm telling the compiler how to implement the setAge and setName methods. And they would be re-implemented differently if I changed any of those attributes. Yeah?
Could you comment on the difference between copy and retain?
Good question. So this will get a little easier, I think, when we have some more concrete examples. But really the motivation here for the string using copy is that there are some classes that come with the various Apple frameworks, like string, where there's a subclass that's itself mutable. And the problem specifically I'm trying to avoid here is if Alice is handed a string that's by nature mutable. It means it can be changed by someone. And I simply retain that. Because it's mutable, it means someone outside of the context of Alice's own setter could change the spelling of her name just because, and Alice wouldn't realize it. The name would just be changed on her. So with copy, I'm making sure I get my own version of ALICE that no one else can ever change. And the only reason I'm worried about that is, again, because of this mutable subclass. So it might not apply in all cases, but certainly with strings, it's the common case. With things like arrays and sets, dictionaries, as we'll see, you could use copy semantics, but generally if you're passing large data structures around, you probably want to share the instance and not create big copies of these things. So retain would suffice there. So let's, question.
With the at property, are there defaults, like can you leave out non-atomic? And
You can. So I'm trying to be pedantic here for tonight, but assign is the default. So I could have left this out for the int, but here I want to specify copy explicitly. Atomic is, for better or for worse, the default. Probably hedges accidental bugs in multi-threading environments, so you have to override that one explicitly. Read-write is the default. So you'll see an example too. I started to get bored with retyping this all the time, so I just leave out read-write and only write read-only if I don't want a setter. Good question. All right, so let's take this one step further. Students 5. What can I do here? So in students 5, notice my .h file is now identical. So we're making some progress. We're sort of happy now with that implementation. So what might have changed here? Well, let's look at student m. Or actually, let's look at main m. So notice in main.m, I just have a silly play application that's pretty much copied and pasted from before, but this time I decided to add David to the student list. So I've got Alice, I'm using my new favorite dot notation, Bob, and David, and notice that David's age 33, name @David, I'm greeting David, releasing David. Let's see what happens. So I'm going to go ahead and run this code. Notice, or take my word for it, that I've synthesized these properties, so I didn't bother implementing my getters and setters, as is kind of implied by the fact that I had no declarations of them in the header file. So I'm leveraging @property and @synthesize. Let's run this program. My little command line will pop up. And notice what happens down here. If we enlarge the text. Interesting. Feels like a special case, hopefully. Right? So it said David a moment ago, but now, for those in back, says hello dummy. So how is this happening? Well, it was a perfect segue, your question before, about manually overriding methods if you don't actually want all of them implemented for you. If I now look at what's actually going on in student .m, notice that I did synthesize age and name, but I also said, you know what, I'm going to manually implement set name, so I'm going to go ahead and implement it as follows. Now the specifics here well, let's work through the syntax. The functionality here is just silly. But the goal was I wanted to make sure that anyone named David had his name changed, but everyone else passed it through unaltered. So I'm using my syntax from before, make sure that my instance variable does not equal name. And notice here what's cool about synthesize is that I know that underscore name exists, even though I didn't declare it in my H file, because I did declare a property and then synthesized it with an ivar called underscore name backing it when I used @synthesize in my .m file just a moment ago. So I'm first making sure I'm not accidentally being given the exact same object. I'm releasing whatever object I currently have, if any. Might be nil, but that's fine. And now I'm saying if name, which is an object I was handed as a parameter, is equal to string. So just like in Java, you can't just compare references if they're strings. You need to do like string.equals. If it's equal to the string @David, well, then I want to do the following. I want to assign to the name ivar, instance variable, an NS string, an allocated NS string. So I'm dynamically allocating memory. And I want to initialize it with, @dummy. And therein lies the little trick. Now, otherwise, if you don't actually equal David, I'm just going to make a copy of your name. So this is identical to the line of code earlier. Now, as an aside, this is probably the new syntax, the fact that I'm allocating a string, then calling this init with method. But I needed to make sure I was getting my retain and my releases right. I didn't want to take a shortcut and just say, oh, you know what? Well, let's go ahead and say at David here, because now I'm not explicitly calling alloc, which means I better not in my dalloc be calling release if I myself did not alloc that string. And so again, just to be consistent here, and we'll spend more time in future examples on memory management, just notice the similarity. I'm making sure that in this case I'm calling copy, in this case I'm calling alloc, but that is okay because again, the rule of thumb at this point in the story tonight is that anytime you call alloc or copy, anytime you call alloc, copy, or retain, you must call release. So I don't have to use the exact same methods, but at least one of those. Yeah?
So are you still doing a deallocator and releasing this string, or did you get that for free with the property?
Unfortunately, I don't get that for free. With the synthesis, I have to implement dealloc myself, which kind of makes sense because I could be doing a lot more juicy stuff in the student class that I really need that control over, the release thereof. So I do have to know what IVAR name I chose in the synthesis process. And so I have to release name, and then whatever my parent class is, tell him to do his thing as well. But I don't have to do that for underscore age, because again, age is not an object, it's just a primitive. Yeah? Good question. No, I don't think so, but we can test this. So the question is if I change the order of some of these declarations. OK, so yes, it does matter, much like it would in a C or C++ compiler. So yes, order matters. So this style of putting them at the top is actually good practice anyway. Those will go away once it actually finishes saving properly. OK, yeah? Oh, yeah, sorry.
Can you put those in the header file? Or?
Put which in the header file? Synthesis should go in the .m file in the actual implementation, particularly so that you don't get those synthesis lines included if someone else is using your header files. So almost always definitions, code that you write, and implicit here is code that's being generated for you, goes in the .m file. Only declarations, like your class definitions, method declarations, global variables, should go in the header file. It would be like writing your methods in the .h file, where so just as a design decision doesn't belong. Yeah?
What's the meaning of the if underscore name does not equal name?
So this is just to be sure that in weird corner case, if Alice is passed her name again and it's an identical object, what we don't want to do is release that name because now it's my current name, because now it just means I decremented my reference count to 0, and yet I'm presumptuously still hanging on to that, so I need to make sure to avoid that. Now I could avoid the if condition and just retain it first, then maybe goofily release it, but this way I'm just not bothering touching the reference count at all. Good question. All right, so a couple last enhancements here. Let me open up version 6. I was really on a roll at this point, as you can tell. So what are we doing here is initialization. So I'm getting a little tired of manually initializing things with my properties, with my arrows, with my explicit calls to these setters. So let's actually start following some best conventions here by having init methods. The convention, the name init, I-N-I-T, just a convention. You could call it foo or bar. Don't. But here, we're going to go ahead and declare init with name, and it's going to take a name parameter, and age, and it's going to take an age parameter. And we saw a preview of this in the keynote slide a moment ago. So this is now just going to be a method that I can call after calling alloc, so I can just kind of prepare this object all at once. So let's take a look at the implementation of this in the .m file. Notice I have two. I didn't bother declaring the init method because I get that for free in the NSObject class, but that doesn't mean I can't implement my own. In fact, I decided just so that I don't get some weird, funky object that has no name, no age associated with it, I decided that in my default init method, my implicit constructor, if you will, I want to, one, call my parent class's init method, which doesn't always have a material effect, but absolutely should you get in the habit of doing in case you start subclassing other classes. And this is just a sanity check. If I allocate a student object but don't manually set his name or property, he's going to be named John of John Harvard fame, and he's currently, I did the math, 403 years old. So that's going to be my default student object, just because, didn't need it strictly. But here is my more explicitly named initializer, init with name and age. I again do this pattern of checking that I actually get back an object from my superclass's init method. Now I'm going to go ahead and use those properties that I myself chose to synthesize for me, then I return self. And recall from last week that self is quite like this, self-referentially. So you do want to return that. And notice too the curiosity here that these init methods return IDs as a matter of convention. You could more explicitly say they return student stars, but generally init methods would return ID, which is pretty similar to void star, but it just means this returns a pointer to an object of some sort. So ID is the convention there for any of these init methods. Any questions? All right, so that was a lot. Why don't we go ahead and take a 3-minute break, and we'll return with a few more features and fun. All right, so we are back. So just a couple of more teasers of syntax, and then we will dive headfirst into actual iOS and some iPhone simulations and start using this stuff to develop the mobile applications you've been promised. So in this 7th example, student 7, I just wanted